me my question in mass. I want my answer in mass. Alright? Calculate the number of grams of calcium phosphate fluoride that are required to react with 686 grams of sulfuric acid. Now, yes?
I was going to say, so then you skip the first part.
No, you can't skip the first part. How are you going to say
You don't need to convert anything.
But why?
Because it's already...
But don't you need to do your multimole conversion? Your multimole conversion, the units here is moles. The units here is grams, so therefore what do you need to do? You need to change it to
moles.
You first convert this to moles, you're given to moles, then you do your multimole conversion, and then you end it by converting that moles to grams.
Yeah, because I'm
So 600.
So now we have 3 sets of conversions to do, right? So what's your first one?
Grams to moles.
What's your first given?
686 grams of
686 grams of
sulfuric acid.
sulfuric acid. What do we need to do now?
Mole to make a mole.
Convert this to moles. So we have 98 grams over 1 mole. Grams cancel out. What do we get? 7 moles of sulfuric acid. You take this. This is your new given now. So you have 7 moles of sulfuric acid. Now, how do we convert this? What do we want?
5 mole, like mole to mole.
Now we do the mole to mole ratio. So again, grams to moles, then mole to mole ratio. So here, what goes on the bottom?
5.
5 moles sulfuric acid. On top,
1 mole of CA.
so now you cancel this out, multiply across, divide by the bottom, what do you get?
4.
1.4
Mole of calcium
moles of calcium phosphate fluoride. This is now your new given. You take this, bring it down. 1.4 moles calcium phosphate fluoride. So the last step would be what?
Find the molar mass of calcium.
There you go. Moles to grams. So now we need the molar mass of calcium phosphate fluoride. What is the molar mass of calcium phosphate fluoride? How much?
485.
Nope.
5. What's CA? 504.
504. How do we get 504?
Yeah, 504.
CA.
Calcium is 40.
So calcium, how many calciums do we have? 5 times 40
Plus 3 times 30 for the first
for
one.
phosphorus,
Yeah.
3 times
31.
31
Plus
Oxygen.
oxygen, which is
12 times
12 times
16
16
And fluorine is 19.
plus
1 times 19. Altogether 504.
altogether 504 grams per mole. So how does that set up in here?
504 or 1 mole.
Moles cancel out, multiply across, divide by the bottom, what do we get?
705.
705.
0.6.
3 significant figures.
706.
706. That's what I got too. Do we get this? What confused you, Jay?
No, I just accidentally forgot to include a mode map on the form.
I figured as much. Do we get it? Yes? Try another one. Calculate the mass, calculate the number of grams of ammonia formed by the reaction of 112 grams of hydrogen gas. How much? Of course. First step. So 634.78. Huh?
261?
261. We have like 5 different answers. What's the first step? Convert your grams of hydrogen gas to moles. What is the moles there? 56 moles. Good. Did we get that? How you figure it's 28?
Wait, no. I thought the thingamajig, the first, the grams over there was 28, no?
What grams is 20? Look over here. What's on the outside?
112.
112. What is the conversion factor? What is the molar mass for hydrogen gas? Huh?
2. Well, there's 2.
2. So where does it go? On the top or the bottom? The bottom. So it'll be 112 divided by 2. So that gives us 56. So now we have 56 moles of hydrogen gas. That's your new given. Now what do we need to do? So you have your mole to mole ratio. So what is your mole to mole ratio? Who goes on top? 2 moles of ammonia and 3 moles of hydrogen gas. You cancel out your hydrogen gas. Mole can multiply top. 56 times 2 is what? Divided by 3. 37.3 minus 2 of ammonia. This is not grams, this is moles. We're still into moles. Moles of ammonia. So now we have that 37.3 moles of ammonia. Now we go into your moles to grams. So now now we need the molar mass of ammonia. What is it?
17.
17
grams
per mole. So where does your 17 go? On the top. Your 1 mole is at the bottom. You multiply your 37 by your 17. What do you get? So 635. So here, what we're talking about, 112 grams of hydrogen gas.
So you're gonna have
Here you're converting it to
56, right?
moles. This gives you 56 moles
18.6.
of hydrogen gas.
18 point, yeah.
You take that 56, you do your mole to mole ratio. 56 multiplied by 2 gives you, divided by 3 gives you
Multiply that by
37. So you take now that 37 moles of ammonia and you convert that to grams using the molar mass. So 37.3? 37.3 times 17,
It's 334.78.
334.78, and the correct number of significant figures are 3. So therefore, we have 635
635.
grams of ammonia. Yes. Do you get that? You point something. Point. No, you. I don't know. You're not seeing that.
What did you get again? 634?
634.7. You rounded somewhere. That's why. Yeah. Right. Okay. So now we have an alternate way to do mass to mass. Some people think it's easier, some people think it's not. Okay? It is totally up to you which one you choose, either the alternate way or my long way. Okay?
I'm slow, I like to see it going.
Alright. So here you're going to, in order to do the alternate way, you need to fancy up your chemical equation a little bit. Alright? So here's what you're going to do. You're going to get the molar mass of each of your reactants and each of your products, and you're going to multiply that by the coefficient. This is where we mess up. Not multiplying the molar mass by the coefficient. Alright? So here, what is the molar mass of nitrogen gas?
28.
What's my coefficient?
1.
28 times 1, that gives you 28. Hydrogen gas, what's the molar mass of hydrogen gas? 2 multiplied by your coefficient, you get 6. Your ammonia is 17, multiplied by 2, you get 34. Once you do this fancied up, you no longer have to use moles. You can go straight mass to mass. Ooh. Do we get that? Alright. So here, same question that we did before. Calculate the number of grams of ammonia formed by the reaction of 112 grams of hydrogen gas. Now we're going to do mass to mass instead of going through the 3 steps. So what goes on the outside? 112 of hydrogen, 112 grams of hydrogen gas. What goes in your brackets now? 34 grams of ammonia on top and 6 grams of ammonia of hydrogen gas, at the bottom. You cancel out your hydrogen gas, you multiply across, divide by the bottom, you get the same thing.
Faster.
Well, not necessarily, because you have to find the molar mass of all of these. It ain't gonna be this easy. Do we get that? What's the matter with you?
I get it, but I'm slow, so I need to see it out, so I'll rather go through the
You rather go through this?
Yeah, I'd rather go
Alright.
through the steps to see exactly what I'm doing.
There you go, that works for you. This is why I give you 2 options.
Sir, will we have any way
Now let's take another question. Now, this is the alternate way. We must do the alternate way.
What is it?
Huh?
What is it?
So now this is a little bit more advanced. You gotta do a couple steps before you can get to your answer. Alright? So here's my question. Listen to my question. Calculate the number of grams of nitrogen gas formed by the decomposition of 32.5 moles of sodium azide.
Gotcha.
So now we have to make up the equation.
There you go! What do you start with the equation? N3
And sodium
to give
Sodium and nitrate.
Na and
N2.
nitrogen gas.
Nitrogen gas.
That's it. You just wrote your own equation. Now what do?
Balance.
You gotta balance it. How do you balance this? Give me my coefficients.
That is 2.
2,
And Na2.
2.
And 3.
Look at that. Only time before y'all taking this long time to balance out. Now you can just read it off. Yes.
Okay, so that's mean the metals, this not goes to Na2 with like the bottom one?
No.
No.
And Na2? No.
Metal is like always like coefficients. It's not gas. So gas only form to H2, N2, right?
What?
The gas.
What about the gas?
The gas only like make it like N2, H2, like in the bottom.
Yes.
And the metal is not like that.
No, metals aren't. There's no metals don't do that. We'll see more of that in a couple chapters down the road. Now what do we do? This is the alternate way. What do we do now?
Mass.
Calculate the mass. What's the mass here?
23 plus
23 plus
42. 3 times 14.
3 times 14.
42. All over.
All of this is 42?
Times, whole 22 plus.
It's 130.
All of this is 130?
Yeah, 130. 130 grams.
So exactly how we got that? We have sodium, we have nitrogen, 3 times 23 grams per mole
2 times 14.
times 14 grams per mole. This gives us what?
All together is 65
65 grams per mole
Times 2.
times
times
2.
2 gives you 150.
130.
Right? What about over here?
43 times 2.
28.
46 grams over here.
Oh, oops.
28 times 3. 28 times
84 grams. Right? So we just fancied up our equation. See, that took less than 2-3 minutes.
3.
Right? So now, what do? What you're given, which is what?
130.
32.5 grams sodium azide.
Azide, you said?
Azide. A-Z-I-D. E. What goes in here?
84 gram of nitrogen
Where?
on top.
And nitrogen gas.
Gas, nitrogen gas. Over 130 gram of, what is it? Iodine?
Sodium azide.
Sodium azide.
Cancel out. Multiply across, divide by the bottom, what do we get?
21 gram.
21 grams.
Of nitrogen gas. Plus.
That's what I got too.
This alternative way only works for
All of them. All for mass to mass only.
So that means we have to understand your question first because you're gonna put some confusion.
How do you think I'm gonna put some confusion? This is simple.
No, you're gonna put some like decomposition because if you don't see that, then you'll.
No, I will tell you what the reactants are. And I will tell you what the products are. You now have to figure out the equations.
Oh, yeah, they're nice.
Okay? Now, limiting reactant. Alright? Limiting reactant is simply which substance is in the smallest amount in your reaction. Alright? So, if we were to flip this equation, what would it be? Flip the equation.
Sodium is limited.
2 sodium
plus 3
plus 3
nitrogen gas.
nitrogen gas to produce 2 sodium azote.
Exactly.
Okay? Now, the question is, of your reactants, which one is in the least amount?
Sodium.
Sodium. Okay? So let's say this is a what to what ratio?
2 to 3.
3. If, for example, let's say you had 2 moles, 2 grams of sodium, 3 grams of nitrogen gas. You reacted these two together. They're going to go to completion, right? If you now had 1 gram of sodium, 3 grams of nitrogen gas, which one is going to finish first?
Sodium.
Your sodium is going to finish first. So therefore, your reaction can only go as far as your least amount. So your sodium is going to dictate how much of your sodium azide you're going to get. And you will have excess nitrogen gas. This is what your limiting reactant is about. So if we look here, for your water, so we have hydrogen gas plus oxygen gas to produce H2O. What's the balancing here? What's the coefficients here?
2 H2O.
2,
H2 and 1.
1,
2.
2. Alright? So what's the ratio for your reactants?
2 to 1.
2 to 1. So you need 2 hydrogens for every 2 hydrogen gas for every 1 oxygen gas. Alright? So if you look here, you have the whites are oxygen gas, hydrogen gases, the reds are oxygen gases. We have 10 hydrogen gas and 7 oxygen gases. Which one is going to finish first?
Hydrogen.
How you figure oxygen? Okay, let's take it back. We saw that there's a 2 to 1 ratio, right? 2 hydrogen gases for every 1 oxygen gas. How many oxygen gases do we have over here? 7. That means how many hydrogen gases should you have to get rid of all of those oxygen gases?
14.
You need 14. But how much do you have?
10.
So which one is going to finish first? Your hydrogen gas is going to finish first, so therefore you end up with 10 molecules of water, 2 molecules of oxygen gas left over, and your hydrogen gas is your limiting reagent.
So what is the shortest and the limiting?
Whoever is going, not whoever's the shortest, whoever's going to finish first. You have to look at the ratio also. Alright? So now we can take a limiting reactant question that I'm going to have to make up over the top of my head. So let's just take these. There's this equation. Alright? And we're flipping this. Yeah, let's flip that. Is it 3?
Yeah.
2? Alright? So here, if you are reacting 6 grams of nitrogen gas and 6 grams of sodium. Okay? much, the question is, if you're reacting 6 grams of sodium with 6 grams of
Nitrogen gas.
nitrogen gas, thank you, how much sodium azide would you get?
No.
No. You must go through the steps to figure out from your sodium, however many sodiums you have, how much of sodium azide you would get. From your nitrogen gas, how much sodium azide you would get. Whoever is in the least, that controls how much product is created. So now let's start with sodium. What do we start with? What's given?
6 grams.
6 grams of sodium. What do we need to do with this first?
Divided by 2.
Convert it to moles. No, divided by 2. Convert it to moles.
Oh,
So what goes in here?
1 more sodium.
1 mole.
Sodium over 23 grams.
Grams cancel out. Multiply across, divide by the bottom.
6 over 23 is 0.26.
Oh, we could do the alternate way for this one as well.
Oh, yeah.
Just so you know.
What you figured out?
You want to do the alternate way? No? Yes?
Yes.
Yeah.
So this was how much?
23 plus 46.
46. This was? Yes?
84.
I'm kind of confused as to what we're trying to find.
Okay. Don't worry. I'll explain it. What was this again?
That'll be 84.
84.
150. All right. So let's bring it home. Okay. Let's say you have $2 in your pocket. Okay. You can't need gas. For every $1, you get 2 miles. So you're going, you put your little $2 in your pocket. From your pocket, you put that much gas in your car. Okay, so how much gas do you have? How much miles can you get with your $2? 4. All right. Now, Keith have $5 in his pocket. Same gas to money ratio, mileage to money ratio. So both of y'all need to get to school. Both of y'all need to drive 10 miles. All right? Who is going to get to school with the amount of money that they have?
Both.
Both?
Equally.
Exactly. She's gonna stop. Radha's gonna stop after 4 miles. She can't go any further. But Keith now, he has up to 10. So he can go the full way. But we only go as far as our weakest link. So who's going to stop first? Radha. Same thing here. We need to figure out which one of these is going to run out first as when we're trying to get to our end point. Right? So let's do the alternate way. Alright? So here.
6 grams of.
What goes here?
To 46 grams.
46 grams up top.
130 grams.
130 grams of your sodium azide. Let's set up the next one. We have 6 grams of nitrogen gas. What goes in here? 130 grams
84.
of sodium azide over on the bottom. 84 grams of nitrogen gas. So now,
Oh,
yes?
I was gonna ask, is there a way to like do a
follow the steps. You gotta follow the steps. Okay? Sodium cancels out. Nitrogen gas cancel out. Multiply across, divide by the bottom. What do we get here? Let's see.
Thank you.
16.9.
How much?
16.9
16.9
gram of
grams of sodium azide.
azide.
What about this one?
9.29
9.29 grams of sodium azide. So you have 6 grams of each of them. Who is going to finish first?
nitrogen.
Your nitrogen
Gas.
gas. So therefore the maximum amount of sodium azide you can make
9.29.
is 9.29 grams.
That's the answer.
That's the answer. So the question would be, which one is your limiting reagent? You would tell me sodium, nitrogen gas, and you would tell me how much sodium azide will be created.
10 points.
10 points.
Not adding anything there.
That I agree with you.
Can you do another question?
Question? Go ahead.
Do you have another?
What is it?
Professor,
It's
6
11:30.
grams there,
One
that
hour.
would be something.
Give it. I don't have any in the top of my head.
Because like, it's
6 minutes.
hard for me to understand the sense. Like, the limited reacting, it's easier for me to just look at it and then like,
No, you can't just look at it. You have to actually calculate it.
so the calculations would be.
10 portion. So it's like 6 seconds per portion.
Just as we did here.
6 minutes? No, 6 minutes
So
per portion.
I think it's over there where you can just
But
look
I
at
don't know
it
A, B,
and
C, D, okay?
see which one is like in the least amount.
6.
Right. But
So
then,
the least amount over there is the limited reactor. correct?
yes.
So that would be the sodium in that case, because it's 3.
Where? No,
Wait,
both of these. No, this one you mean here?
no, below where you did
This
the
one.
calculations. No, lower.
This one.
Yes.
So remember, both of them had 6. So now we need to figure out, of these 6 grams each,
Okay.
how much will you get of your product from 6 grams of each?
Okay.
So your nitrogen gas will only make 9.29 grams of your product, but your 6 grams of your sodium will make 16.9 grams of your product.
So the limited is the,
Yes.
so the limited reagent is the nitrogen gas?
Yes.
Two.
All right, let's see what's next. Theoretical yield. We almost done. Promise. Promise. We almost done. We almost done. Okay. Now, theoretical yield is simply what's supposed to happen if everything goes right. When you get into the lab, everything goes right. Every reagent behaves exactly where the reagent is supposed to. Everybody reacts the same, exactly how it's supposed to. This is what you're supposed to collect in the lab. That is what you've been doing. All the calculations that we just did, multimole, multimass, mass to mole, mass to mass, all those calculations, that is your theoretical yield. Okay? So I can tell you, calculate the theoretical yield of X, Y, and Z. Okay? That followed with the same questions that we did before. Okay? So again, same thing that we just did, now you know the name of it. It's called theoretical yield.
That's chemistry language.
This is chemistry language. We are in chemistry. Okay? Now we have the actual yield. The actual yield, when you go to the lab and reality hits, and you try this experiment, and all the little side reactions take place.
Like the first one that we did. Because the first one had the decomposition as well. So we had the carbon dioxide and water instead of.
No, that's something different. So you'll figure out, I think we might be doing theoretical yield at some point. But your actual yield, this is what you actually collect once you actually do the experiment in the lab. All right? And that will be given to you. So now we have a question. You have this equation. Can I get this read in a sentence? Bless you. Ronnie,
With the sodium,
ah!
1 mole of sodium sulfate, sulfide
Uh-huh,
reacts to 2 moles of
silver,
silver nitrate to produce 1 mole of silver
no, not fluoride, sulfide,
and 2 moles of sodium nitrate.
very good, okay? Here's my question. How many grams of silver sulfide will form when 3.94 grams of silver nitrate and an excess of sodium sulfide are reacted together? Anytime you see excess, that means you have an abundance of this. So now, which one is going to be your limiting reagent between the two that's reacting together? Silver who? The silver nitrate. That is your limiting reagent. So now, how are we going to do this? We can either do this the alternate way, because remember, we're going from, what kind of question is this? Mass to mass. So we can do the long way, or we can do the alternate way. Alternate way? Okay. So what are the two, for our conversion factors, what are the two things that we're interested in?
I have a question.
Yes.
You know how you multiply everything by the coefficient?
Yes.
The question is only asking for certain elements, for certain compounds.
Yes.
You just multiply those certain compounds?
Yes.
Okay.
Okay? So who are we interested in?
Silver nitrate.
Silver nitrate and
Silver sulfide.
silver sulfide. Now let's find the molar mass for silver nitrate. Lord, something sticking there.
108. Silver is 108 and
Yes.
it's 248 grams.
Which one? This one?
Silver.
This one? This one is?
This one is 145.
186?
Yes,
No.
164.
I have 186, 140 something, 164. Which one is it? What are we doing?
14.
Okay, so silver is 108.
yeah.
Nitrogen is 14. Oxygen is
16 by 4, 3, oh,
60. Oh, see, somebody did something.
48.
16 times 4, which is
3,
64.
3.
Times 3.
I made a mistake
Oh.
on the 4.
Times 3.
Minus 3.
That's true.
So what do we have here?
170.
48.
Only 170.
170.
170 grams.
There you go. Now, what do we need to do with my silver nitrate?
Multiply by the coefficient.
Multiply by a coefficient, which is 2. So this is
340
340.
grams. Oh, okay.
All right. Now your silver sulfide, what we have here?
248 grams.
248
grams.
grams. Does that say? What's our coefficient?
1.
1. Good. So we have our two masses. What goes on the outside? 3.94
Silver nitrate.
grams of silver nitrate. I'll bracket what goes on top.
Silver sulfate.
Silver
Sulfite.
sulfide. So 248 grams of silver sulfide. On the bottom goes 340 grams of silver nitrate. Silver nitrate cancels out, multiply across, divide by the bottom, what do we get?
2.87
2.87 minus 2,
grams.
minus 2,
Silver nitrate.
silver who?
Oh, silver sulfate.
That's what I got too,
So that's
2.87.
like.
I did it the long way, I like the long way.
So we don't have to think about other things, like other.
No, you don't have to think about anything else, just what the question is asking you about. Yes,
Snap a picture of that right there,
what?
the previous slide. Yeah, thank you.
Alright, so now, let's go with our percent yield. Percent yield is simply, what is the percentage of what you got based on what you were supposed to get? So you have your actual yield divided by your theoretical yield times 100. Remember, your actual yield, I'm going to give that to you. Alright, so now let's take another question. If 2.87 grams of silver sulfide will be produced from 3.94 grams of silver nitrate, find the percent yield of silver sulfide if the actual yield is 2 grams.
So what was the question, actual yield?
Actual divided by theoretical times 100.
So 2 over 2.87
Yes,
into times 100.
yes.
70%.
Forget about that.
How many significant figures do you need?
3.
So what's my answer?
69.7.
Minus 2,
What's this?
69.7%. That's it.
You don't give it